Hey guys, let's do it. So it says, how are properties of similar figures used to solve problems? All right, so we solve problems with angles because we know they're the same. And we solve problems with sides because we know that they're the same ratio. So we've used similar figures for thousands of years. An example is, putting maybe a mirror on the ground, and this is a person. And this is a tree. And figuring out the height of the tree using the similar triangles. This idea of two angles, two angles, the angle similarity, or using side angle side similarity, or side similarity, then solving for unknown information. Okay, so two triangles that are blank have two pairs of corresponding congruent angles. Two triangles that are similar, right? And this is true because of angle similarity. A blank is a composition of a dilation and one more rigid motion. So that would be a similarity transformation. A point that is its own image in a dilation. A point that is its own image in a dilation. I think that would be our center of dilation, and I'll explain that here in a minute. So if I took the triangle ABC and I dilated it about point A, then let's say I tripled it. This A prime would be at its same location. As a result of a dilation, A prime B prime is equal to N times AB, then N is called our scale factor. So we usually say our scale factor is new over old. So you can see algebraically, new would be A prime B prime, and old would be AB. And that's the same equation, just if I decided to divide AB on both sides. Nice. So now we have our definitions. Let's get into problems that we explored in 7.1 and 7.2. So it reviews our vocab words, and we see that these are definitely similar because we can reflect it over the y. So it would then be here, right? And then blow it up twice as big, right? Now looking at number 6, it says, what are the coordinates for D1/2? Okay, so that means we have to multiply each one by 0.5. All right, so I'm just going to write 6 over here, right? So F prime would be 2.5 and -1. G prime would be -1, -2, and H prime would be 0, 3. Now looking at number 7, this would not be on the test because we wouldn't have to dilate from a point without graphing, and I'm not going to have you guys graph. All right, number 8, what is the similarity transformation from PQRS, from this guy to that guy? So there's a couple of answers here, right? But it looks like it has the height of 3, and now it has the height of 1. It has a width here of 3, and now it has a width of 1. It has this width of 6 up here, and now it has a width of 2. So our scale factor, if the new one is 2 and the old one is 6, see how that's a ratio of 1/3. So it looks like we need to dilate it. I think we can do it about the origin, so let's dilate it by 1/3, right? And I want to do that first. And then it looks like I want to flip it over this line which would be, it's parallel to x, so it'd be y equal negative 1/2. So reflect over y equals negative 1/2. So that's 8. It says, Isabel says that the scale factor maps this one on top of that one is 2. Well, it looks like no. These are not similar. Or maybe they are. Let's try that. This is our biggest angle, so maybe they did like rotate this a little bit, right? So how do we check out whether or not they're similar? Let's order the sides least to greatest, right? 4, 5, 7, 8, 10, 14. Oh, and what do you know? They are similar because they all equal the same ratio, 0.5. Okay. So is it correct to say that this shape maps on top of this with a scale factor of 2? No, it's the scale factor is 1/2 because from ABC to PQR, it gets smaller. Nice. All right, next one. We look here and we notice 2 pairs of angles, right? This is angle similarity. This is side similarity in words. And then this is talking about the included angle. This is side similarity. So looking here at this shape, we see that they're parallel, which is actually angle evidence. That tells us these 2 angles are equal and these 2 angles are equal. Nice. We also know these 2 angles are equal because of vertical. So that's angle similarity. All right, looking at 10, we see would this triangle, FGJ, be similar to JGH? All right, we can set this up. So it looks like we can set it up with the baby, small, medium, small 4, medium 6, and then with what looks like the teen, small 6, medium 9. And we know that this angle in between is a 90, so that angle is matching, right? So that would be 0.6 repeating is equal to 0.6 repeating. That's 2 sides. And we know the angle is a match because both of those are 90 degrees, right? Angle G and angle G are equal in both 90. So we're going to say yes, side angle side similarity. What about this next one? So we'll compare triangle KLN with triangle NLM. Okay. And it appears we know all 3 sides. So let's order those sides least to greatest, 2, 3, and 4. And then those sides least to greatest, 4, 6, 8. We end up getting point. Yep, these are all equal to the same ratios. So we'll say yes. Side. All 3 sides make the same ratio. Number 12 states, explain what additional information is needed for angle. Okay, so first let's figure out what U is. So we take 180, take away 37. So that'd be 143, right? And then let's take away 65. So that'd be 78. So we currently have one angle Z and angle U, that are 78. So what additional piece of information? They're admitting this is not enough. We need a second angle, like T to match. We need angle T to be congruent to angle X, or we need the last 2 angles. We need angle V congruent to angle Y. So since we know angle V is 65, then we would need angle Y to be 65, or since we know that angle T is 37, we then also need angle X to be 37. So either of those pieces of information would be helpful. All right, check out the next video for this last section.